Alright, let's look at the homework 4.3, problem number 9. Alright, so we want to find the vertical asymptotes. Alright, so vertical asymptotes. So you can see that the denominator is x and x squared. And these things will blow up when x equal to 0. So x equals 0 is the vertical asymptote. Alright, so we got that. Alright, in order to find horizontal asymptotes, all you have to do is take the limit. So we have a limit of this function, 1 plus 5 over x minus 8 over x squared. As x approaches either positive infinity or negative infinity, in this case it's actually exactly the same, because second term, 5 divided by big number approaches 0. A divided by big number squared is going to approach 0. So this is going to give you 1 either way. So horizontal asymptote is y equals 1. Alright, so we got that. Alright, so interval where the function is increasing and decreasing. So we have to look at the first derivative. So I'm going to take the first derivative here. Actually, I'm going to rewrite the function first. Alright, so this is 1 and plus 5. 1 over x is x to the negative 1 power. Alright, negative 8 x to the negative 2 power. Alright, so if you take the derivative of this, f prime of x is equal to, derivative of 1 is 0. Derivative of this guy is negative 5 x to the negative 2. Alright, then it's going to be plus 16 x to the negative 3. Alright, so what you're going to get is, let's see, so we can probably rewrite it as negative 5 over x squared plus 16 over x cubed. Alright, we can combine this by taking a common denominator, which is the x cubed. Alright, then you have negative 5x, and you have a 16, so I'll just to change the order there. Alright, so we can set that equal to 0, and we have, so we set the 16 minus 5x equals 0. Then you can see that this is going to be, let's see, subtract 16 from both sides, negative 5x equals negative 16. Then we can just divide through by negative 5 to get x is equal to 16 over 5. Right? So this is the critical number. Right? Then we want to probably do the number line. Right? So 0 is a vertical asymptote there, so function isn't even defined, so here's 0. So maybe I'll indicate it as not defined. And so we look at the f prime, and the the critical number is 16 over 5. Alright, so we're going to look at the sign here. Anything less than 0, so I'll try negative 1. Alright, if you plug in, so this is negative 1. Right, negative 1, so this is negative. Alright, negative 1, that's positive. Positive over negative is negative. And we can try anything between 0 and 16 over 5, so I'll try 1. Alright, 16 minus 5 is positive, and 1's cube is positive, so everyone's positive here. Alright, anything bigger than 16 over 5, so maybe 4. Alright, so 16 minus 20 negative, and the positive, so it's going to be negative here. Right, so we know that it's increasing between 0 and 16 over 5, and 0 and 16 over 5. I think the answer is parentheses. I would include the 16 over 5. Either way is fine. Right, so we got that. And then interval where it's decreasing, so that will be negative infinity to 0, and also 16 to 5. So I would probably write it this way, and I would include 16 over 5 to infinity. Either way is fine. Right? So we got that. So let's look at the parts. Alright, for part C, we want to find the local maximum value and the local minimum value. Alright, so looking at the sign of the first derivative, we know that the function is decreasing here, and increasing here, and decreasing there. Right? Then you can see that you would think that there would be a local minimum here at x equals 0. But the bad thing is function is actually not defined x equals 0. So there is no local minimum. Right? But here, increasing turn into decreasing, you would have a local maximum there. Right? So we would have local maximum value would be, we plug in 16 over 5 into the function. You have 1 plus 5 over 16 over 5 and minus 8 over 16 over 5 squared. And I would think that this is going to turn out to be 57 over 32. Right? So that's why it's 57 over 32. Right? And there is no local minimum, so it does not exist. Right? So we got those. Alright, then we want to find the interval where function is concave up and the concave down. So we have to take another derivative. Right? So let's see, first derivative is here. Right? Maybe it's easier to take the derivative of that guy. Right? So let's do that. So f double prime, so I'll probably go here, f double prime of x is equal to, alright, put 2 in front, so it's a 10 x to the negative 3 power. Then you have minus 16 times 3. 3 times 6 is 24, so 54 x to the negative 4 power. Right? So we can write it as, right, so this is going to be 10 over x cubed minus 54. Oh, actually, 3 times 6 is, I messed up, so this is not, right, I can't multiply numbers here. Alright, 3 times 6 is 18, so it's a 48. Alright, sorry about that. So it's a 48 here. And over x to the 4th power. Alright, then take a common factor, so common denominator, so that's going to be x to the 4th. Alright, and 10x minus 48. Alright. So factor, let's see if you, so set that equal to 0. So here, x is going to be equal to 48 divided by 10, which is 24 over 5. Right? So we look at the number line again. Right? 0 is not defined, and you have a 24 over 5. Alright, so not defined here. And we look at the second derivative. Alright, then try something less than 0, so negative 1. So if you put negative 1 here, so that will be negative here. So it's negative. And here, after that, let's try x equals 1. Alright, so 10 minus 48 is still negative. Alright. So 24 over 5, so let's try 5, and that's going to be positive, right? So it seems like you have a concave up shape after 24 over 5. So it's a 24 over 5 and to infinity. So we got that. And the interval where function is concave down, so that would be negative infinity to 0. And 0 to 24 over 5. Alright, so we got that. Alright, then find the inflection point. The only place that changes concavity is right here. So you would have inflection point there. So the x coordinate is 24 over 5. Then if you plug in 24 over 5 into the original function, which is 1 plus 8 over 24 over 5, and minus 8 over 24 over 5 squared, you will get 61 over 36. So 61 over 36, right? That's how they got that. Right? That's it. I hope that this was clear.